Hello, this is Psych, and welcome back to my channel. Today I'm going to talk about some technical terms that we use in classical test theory. Classical test theory begins with a simple equation: x equals t plus e. X is my observed score. It's the score that I can see. T is my true score. E is error. Now, I've already created a video about the true score, and I'm going to make a separate video about measurement error. So today I'm going to show you how we can rearrange this equation to obtain certain values. And then I'm going to also use that to get a definition of reliability. So given that x equals t plus e, we can manipulate the equation to see how we can think about t and e, my true score, and error. So like I said, if x is composed of a true score plus error, then we can do some basic manipulations to this equation, and we can see that t equals x minus e. So my true score is going to be composed of the score that I can see, x, after I have removed error. We can do the same thing to get a picture of error. E equals x minus t. Now in this case, error is going to be composed of my observed score, the score that I can see, after I have removed the true score. Now, in classical test theory, we're often more concerned with populations than we are, let's say, an individual person. So instead of using these terms, let's say that x equals t plus e, we're going to substitute the symbol for variance. So we will see this. So instead of x, I have my observed score variance. And instead of t, I have my true score variance. And instead of e, I've replaced that with my error variance. So this is just the same thing, except now we have my observed score variance is going to be composed of my true score variance plus my error variance. And just like we rearranged the first equation, we can do the same thing with this equation. So as we can see, my true score variance, that's going to be composed of the variance that I can see, my observed score variance, after we have removed the error variance. Once again, the error variance, or in a similar way, the error variance is going to be composed of the variance that I can see after we have removed the true score variance. So the difference between the variance that we can see and a true score variance, that would constitute measurement error. So one thing that we need to keep in mind is that my true score variance is really the good variance. It's my systematic variance. It's my reliable variance. Whereas error variance is the variance that I really don't want. So it would constitute noise. We could think of it as noise or variance that's random. So with respect to reliability, we want to determine how much of the variance that I can see can I attribute to the good variance, the true score variance. So I can think about reliability as follows. There's actually a couple different ways that we can think about it. So this is the first way that we can think about reliability. And in this case, we're saying that reliability is equal to the true score variance over my observed score variance. So this equation is a ratio, and it's basically stating that reliability consists of the amount of my observed score variance that I can attribute to variation in my true scores. A second way that we can think about reliability would be with respect to measurement, with respect to error. So let's look at the other equation. So another way that we can think about reliability is, like I said, with respect to measurement error and the absence of measurement error. So let's look at this equation. We have reliability is equal to 1 minus the error variance over my observed score variance. So in this case, let's just look at the latter right-hand side of this equation. I can see that we have a ratio, once again, of error variance to my observed score variance. So this part of the equation is basically saying how much of my observed score variance can I attribute to error. And then we're going to subtract that off from the whole, which would be 1. So like I said, there's a couple different ways that we can think about reliability. We can think about reliability in terms of how much variance can we attribute to variation in my true scores. And we can also think about reliability in terms of the absence of error variance. So let's take one simple example just to see how we could interpret our estimate. So let's assume that we have a reliability estimate of 0.70, which we don't need the zero, but whatever. So this indicates that we can estimate, or at least according to our estimate, 70% of the variance that we can see, we're going to attribute to true score variance, whereas 30% of that variance would be noise, or it's random. All right, so that's all that I have for you today. We've talked about some technical terms with respect to reliability. I've given you more of a technical definition of reliability, so stay tuned for more content.